All right, so today we're talking about cutting out slot jointed furniture. And for this project, we're looking at a model stand. It looks like it's about 3 and some change high and 24 by 24 wide. Here are the primary components, and this is Rhino Cam. So this is probably the file you're going to end up with, something similar to this. There's a lot of extra information here. So what I'm going to start off by doing is just clearing some stuff out here. So I'm just going to delete those overlapping lines, select my cutting material. So these are the shapes. And I'm going to type invert. And then I'm going to delete everything else. You could also hide it if you wanted to. You could probably turn off layers if you wanted to. I'm just going to delete it because I won't need it again. And I'm going to highlight everything here. And I'm going to type move. And I'm going to take this bottom corner and I'm going to move it to 0. This isn't my file, so I'm not sure where my guides are, but they're not here. And I'm going to open up RhinoCam. So if you open this up on your own computer, you're not going to have RhinoCam. You need to open this in the lab computer, and the RhinoCam should automatically load. In the event it doesn't load, I closed it out here to show you how to open that up. You could type RhinoCam into the command bar, or you can click RhinoCam and open up mill. And it should look something like this. We're going to dock these bars over on the side. And you'll notice right now that we do not have any tools in here. And so that's the first thing we're going to do. If you look at my clean desktop, I have a file there that's a TXT, looks like a TXT file. It's not, but it is fall 2024. We're going to load that into here. And so we're going to hover over this and say load tool library. And I'm going to go down to documents or desktop and load from fall 2024. And it'll say 8 tools have loaded successfully. Awesome. So my tools are in here and they're ready to go. I'm going to close that out because I don't need that anymore. It takes up a little bit too much space. And now I have everything I need to get started. The first thing we're going to do, hypothetically for me, I'm going to cut this out of a 4x8 sheet of material. So that is, I'm going to draw a rectangle that is 48 by 96. This is actually not the correct orientation, so I need to rotate it so it is hamburger style. And I'm going to move that to the 0 location. And now I can take my geometry, or what I usually refer to as art, and I can set it in on the board a little bit of a ways. You don't ever want to have your art up against the board. You want to have at least an inch margin from the edge. So this is about 1.6 inches. So this is good. An inch from each edge. That gives you a little bit of agency if you need to clamp something down later. Also, it allows for the tabletop to be slightly out of square. You don't want to follow straight edges along a straight bottom and assume that the table is fully square. And so I'm going to start up here, and there's a number of videos that I've made on RhinoCam, and they all start the same way. But we're going to start off by aligning our stock. And it's a box stock. And what I've done by drawing my 4x8 is I have given RhinoCam something to snap to. If I still had all that errant information here, it would try to snap to everything. So I'd have like a 1,000-inch wide board. So this length looks good. This width looks good. The height is an arbitrary 12 inches, which is incorrect. And so we're going to make this 1/2 inch. You're going to use digital calipers to measure this exactly, but for this purposes, I do believe I have an exactly 1/2 inch board. And you'll notice now my art is separated from my stock material, and that's okay because we're going to align the two, and we're going to align the stock. I like to keep two-dimensional art at the top of my stock, so that's why I'm going to select the Z alignment top. And with the XY alignment, since it fits the bounds of the materials, you can click this any way you want to, but it's not going to change. This will be useful later in your CNC career. Hit OK, and we're looking pretty good. I'm going to show you what's going on from the perspective viewport. This right here is currently not correct. It is something that is independent for all CNCs. You get to define where the 0, 0, 0, the Cartesian 0 point is. And for us, this would be that our MDF or OSB that we're cutting through actually sits below the tabletop. So we need to move this gumball, and you can't click it. So we're going to do align world coordinate systems. And the world coordinate system is the nomenclature for this gumball here. We're going to set it to the stock box. So the stock box appears then at the lowest Z in the southwest corner. And watch where that moves. There we go. Lowest Z, southwest corner. Stock box, lowest Z, southwest corner. Chant it, commit it to memory. This is super important. And then this looks like the perfect setup. So this is looking pretty good. I need to now create the tool paths. And the tool paths is the path that the tool travels to create cuts. And so those are under machining operations. You've got any number of machining operations to do for 2-axis, 3-axis, 4-axis. You can drill holes. You can do this nefarious others. But we're going to do 2-axis. And we're going to do what is called a profiling. This is one of the most simple and basic operations in CNC routing. And it is what you're going to be doing here. And these icons are pretty good at dictating and indicating what it is that's happening. So you can see that we are cutting out a shape. Profiling operation, I tell people, is usually anything that you could cut out of a piece of paper with scissors. And so we'll click that. And we're going to work through each one of these tabs. We may not alter things in any of them or all of them, but we are going to click through each one. And so the first thing it's telling us to do is to select what it is that we're cutting. And so we need to select the curve and edge region. So I'm going to select that. I'm actually going to come back to the top viewport. And I'm going to highlight and select all of these. But I'm going to come back in and I'm going to shift select or control select these 4 slots right here. So these are all of what I'm going to refer to as my outside cuts. It is because these curves are closed, so that means there's an inside and an outside, and we are going to cut the outside. So I'll hit enter now once everything is selected. And you can see I have all of these drive regions. Each drive region, if you click on it, will correspond to an independent line segment. It's sort of a less efficient way of doing things. You could group all these as a single curve, but that's not the case with this file that I was given. So now we're going to select the tool that we are going to use to cut. For OSB, this isn't some furniture quality wood here, so we're going to use what is called a straight cut flat end mill. You will learn so much more about CNC bits as you progress into your CNC knowledge, but for right now, let's just trust the process. You're using a straight cut flat end mill. Select feeds and speeds, and if you've never cut before, this may seem like, this is probably a great place to start. Incorrect. This is a very, very low speed for how fast the spindle's moving. So we need to hit load from tool, and this will give us a decent starting point. So for the CNC and the laser cutters, you're going to start with these suggested power settings, and this is a speed rate, meaning the speed at which the spindle spins, and then a feed rate, which is the rate at which it plunges through material and cuts. So those are speeds and feeds. This is a starting point. This is not going to start a fire, but it's not going to be the most efficient. There are online things called speeds and feeds calculators, specifically one from the Cutter Shop, which I will probably link at the bottom of this video if I can figure out how to do that. And I did that earlier, and I think a safe starting point for this is going to be about 360 inches per minute at 16,000 RPM. So this is the one value right here, this cut feed rate that you're going to change. Clearance plane, this is where I said it's super important to make sure that you establish the height of your stock material exactly, because the clearance plane is the height at which it moves when it's not cutting. And so it only moves a 1/4 inch above the material. So if you put in a 1/2 inch, but your stock material is actually 3/4 inch, it's going to gouge the top of that. So this I just leave to automatic because I know I did my measurements correctly. Then we have cutting parameters or cut parameters. This is where we dictate where the CNC cuts. And so we're not going to mess with any of these top icons here, but down here it says use the inside and outside of closed curves, and if you hover over that, it does a great job of showing you what that means. But basically right now, if you were to just select nothing, it would cut on top of the curve, and you're taking a 1/4 inch bit and you're centering it over your lines. So you're going to be losing some material on either side. And that doesn't really jive well with what I want to create here. And so I'm going to use the outside of these closed curves. And then I'm going to click sorting just to see what it does. I don't have that many cuts, so I'm not going to sort anything. And then cornering parameters. So I'm going to hit generate for a second. We're not going to look at this, but I want to show you all something. So we have these inside corners here. And if I were to create a circle, because we're cutting with a round tool, and that circle has a diameter of 1/4 inch, this is the thing we're cutting with. And so you'll notice that as that bit starts here and starts to move its way into the corner, it actually can't cut out this corner. And that's okay, because we have an option in the toolpath generation to create this corner or to infer this corner. And what we're going to do is, instead of just sort of following this along here, we're going to sort of extend in just a little bit right there so that we have this implied interior 90-degree angle. That is because this is considered slot jointed furniture, meaning that those slots do have to mate exactly. And so that's sort of like the whole thing behind this pedestal, is that these slots mate perfectly. And if you don't do this, you're going to end up with some weird rounded corners and things aren't going to fit nicely. So we're going to take this bit, it's going to come in here, it's going to kick out to the side a little bit, it's going to come back in, and then travel on, kick out, come back in, travel on. So that is under the cornering parameters. That is this selection down here, internal corner shape. And there's dog bone and there's T-bone. I am a dog bone kind of guy because it travels out at a 45-degree angle from the corner there. Now we have to select advanced cutting parameters. And so advanced cutting parameters, we're not going to mess with any of the arc fitting. That is indeed pretty advanced, but I am going to add some tabs here. And what a tab does, if you hover over this, you'll see that it creates a little tab that's going to hold our piece to the greater work piece. So it's going to take this side of a pedestal and it's going to keep it attached to our bigger board. That's because if we cut through it, we may not have enough vacuum power to keep it down and it might try to shoot off across the room. So this is mandatory. We have to have tabs when cutting out profiles. One tab is a pivot point, 2 tabs will make it wobble, 3 tabs it starts to get sturdy, and then we're going to increase up as size dictates. And so we're going to start off probably by adding 5 tabs, or bridges, I guess is what they're called here. And then entry and exit, you don't need to know about this, but I'm just going to select none. And then finally, for this toolpath generation, is cutting levels. You'll see here again our 1/4 inch bit. You never want to step down in a general way greater than half the tool diameter in any given direction. So that means for this purposes, we're going to be stepping down 1/8 of an inch each pass. So remember at the very, very beginning when I said that my art was located at the top, we were at the top here. Our total cut depth is 1/2 of an inch because our material is 1/2 of an inch. And then once I click into another box, it'll say, oh, our rough depth is 1/2 of an inch. And right here, this is one of those things where it says rough depth and it's got this backslash. That means per cut. Rough depth per cut is 1/2 inch. So if I hit generate right now, that means it's going to plow through the whole 1/2 inch. I need to come in here and put 1/8 of an inch. And I know that's 0.125, but if you don't, you can put 1/8. And then you can just click that. And then it hasn't really taken yet, so click another text box, and there we go. That blue slider moved. I'm going to hit generate. I'm going to delete this weird circle. And I'm going to look at it from the side, and I can't see anything. That's because my lines have been turned off. You can toggle any sort of viewpoint down here. So we're going to toggle the toolpath visibility. And here are all my cutting paths for the outsides. And we are almost halfway through. Sweet, that looks good to me. So the one thing I want to check is that if I can see my material and I can see my cutting lines, I want to make sure that my cutting lines don't extend below the 0 point. And this is the 0 point here. on our lab computer. All the grids are turned on so you can see that line across the bottom. So that looks pretty good to me. The next thing I'm going to do from a perspective viewport is I'm going to come up here to simulate, and I'm going to play it. And you're actually going to see, oh, not simulate by move, so simulate the whole thing. You can see this, the actual bit cutting in real time. I mean, real time, more or less. It's going to take a lot longer than that. And then you can orbit around and see where your tabs are all located. You're going to have something to chisel off inside of there. You're going to have a tab there, tab there, tab there. I could probably get away with 4 tabs. Let's see if we can do it. Advanced cutting parameters, 4 tabs. Generate, and then we'll simulate to the end. And so I got a tab there, and a tab on the inside, and a tab there, and a tab there. That's probably fine, but I'll just make it 5 to be safe. And so you'll mess around more with this as you start to understand CNC more. And so now we have to cut the inside of these. And so that's because these have been sized exactly to the thickness of our wood. And so we need these little slots to be a mating part for the top of this pedestal here. And so instead of doing all this again, I'm just going to do Control C, Control V, and I've copied that. And so I'll label this one outside cuts, and I'll label this one inside cuts. Cool. And so really, if I were to send this now, it would cut the same job twice. So I need to come in here, and where it says to select my drive regions, I'm going to remove all of them. And I'm just going to select these 4 tabs. Hit enter, and I've got all these little drive regions now. Now most of my stuff is the same. I've got the same bit, the same feeds and speeds, same clearance plane, but right here I need to change my inside and outside cutting parameters. I'm going to turn that to the inside because now the inside dimension is what matters to me. And then I'm going to come over to corner parameters, and I'm going to make sure this dog bone is still turned on because this is all interior corners and I need those slots to line up perfectly. And then the only thing I am going to turn off now is bridges and tabs. So this is a unique situation that when we generate this and we go to simulate it, it's actually clearing out all of the material. And so we don't need bridges and tabs there. That should clear out everything. And that looks pretty good to me. One thing you will notice though is these tabs are in the corner, and I'm not really a huge fan of that. So that was because we added 4 tabs to the outside cuts. I'm going to throw another tab on there and see if we can't move that around. That's looking better. Now the tabs are all on flat surfaces. All right, and so the last thing I need to do is to export this job to the CNC. Your instructor should be showing you how to do that during the orientation. You will come up here to Setup 1, you will right click and you will select Post. I can't post to the CNC from my computer, but you should be pretty good to go. Be sure to check with an instructor, a lab monitor, or a TA before running your job. You don't ever want to run one of these without running it by somebody else. And good luck.